Hey there, everybody. Mr. Odom here, and today I'm going to cover section 3.5, solving two-step equations. You'll need your pencil, composition book, or notebook paper, and a calculator, and the learning target for this video is I can solve two-step equations. So what is a two-step equation? Well, a two-step equation basically is what you think it is. It takes two steps to go from where the equation is to where the variable is all by itself. So it takes two steps to isolate the variable on one side of the equation. And we're going to do a lot of examples, and you're going to work on some examples in this video. So we're going to use these properties of equality that we've been practicing: the addition and subtraction property of equality, and the multiplication and division properties of equality. Okay, so this was, what sections were these? This was 3.3. This was section 3.4. All right, that's when we worked in practice using these properties by themselves. Now we're going to combine them to solve equations that are a little bit more complicated, and you're basically going to be doing a little bit more work. Okay, so let's look at one of these examples. So let's see, what did I do? For number one, I wrote the equation down, and I look at the equation, and I want to get x all by itself. So what do I do first? Well, first, I want to eliminate that part of the expression on the left-hand side, the 2 times x plus 12. I want to get rid of that 12. So I'm adding 12 right now. Let me subtract 12 from both sides. So I do that, and I end up with just 2x by itself. And then on the other side, I have to do some math. What is 4 minus 12? Well, that's negative 8. So I end up with 2x on the left side and negative 8 on the right side. How do I get x by itself? Well, I need to divide both sides of the equation by 2. So here I use the subtraction property of equality for the first step. So this is step 1. And then step 2, I use the division property of equality here. And now look what happens. I have x all by itself. And negative 8 divided by 2, these two values have different signs. So when I do division, I have negative divided by a positive. My answer will be negative. And over here, all I did was check my answer. I substituted negative 4 in here, and I did the work. And you can see that both sides of the equation are the same. So that means that this is the solution to this equation. All right, so there's a little extra work you have to do, but this is stuff that we've been doing in the chapter. You're just combining it to solve one equation. So I want you to pause the video, and I want you to work out problems 2 and 3 on your own. Write your answers in your composition book, and then we'll take a look at those answers in a moment. If you're watching this on Edpuzzle, then the video will pause now. Okay, so we're back. What'd you get for problem 2 and 3? So there's problem 2. Again, my first step here is to subtract. I'm subtracting 9 from both sides. Subtraction is the inverse operation for addition. And I end up with negative 5c all by itself. And then I divide both sides by negative 5. So there's the second step to my two-step equation. And that leaves me with c all by itself. And I check my answer. And so this is the solution to this equation. Hopefully you got 5. Let's look at this one. So I solved this problem in 2 different ways. The first way I did it right here, and then the second way is over here. Both are correct. Some students like the first way, some prefer the second way. Doesn't matter to me. What I'm concerned about is you showing your work properly, making sure you keep track of negative signs, and that you get the correct answer, of course. So let's just walk through what I did over here. So the first step over here is to recognize that this is 3 times this quantity. So it's multiplication. So I use the division property of equality first. And what does that do? It leaves me with this expression, x minus 4, all by itself. And to get x by itself, so I'm subtracting, the inverse operation for subtraction. Step 2 is to use the addition property of equality here. And I end up with x equals 7. So that's one way you can solve this equation. The next way is the first step is actually let me use the distributive property. So I do that here. 3 times x plus, because it's positive, plus 3 times negative 4 equals 9. And then what I end up with here is a two-step equation. Let me highlight it. Here is my two-step equation right here. So then I follow those steps for the two-step equation. The next step is to use the addition property of equality. That gets the 3x by itself on the left-hand side. And then I just divide both sides by 3 using the division property of equality. And I get x equals 7. So I get the same answer. Is this answer right? I check it. Sure enough, it is. I substitute 7 in there, and it works out. All right, nice job. Okay, hopefully you guys got those answers. Let's look at another kind of two-step equation here. And the study tip is pretty helpful. So it says you can simplify the equation in example 2. This comes right out of the textbook before solving it. So what they mean by simplifying is let's get rid of the fractions. Okay, and how can we do that? It says multiply each side by the LCD or least common denominator of the fractions. So if I look at the fractions, I see these denominators of 8, 2, and 2. I know the least common denominator is 8. So you multiply both sides of the equation by 8. And here's a little secret to that. I can multiply the entire equation by 8. So not by doing this, I'm actually multiplying both sides of the equation by 8. All right. So now I use the distributive property. Okay. So when I do that, what happens? I have 8 times x divided by 8. And remember, this could be written as 8 over 1. And then I have 8 times negative 1/2. And that equals 8 times negative 7/2. And remember, I can always write a whole number so that it looks like a fraction. Now what do I do? Well, let's clean this up a little bit. I can go ahead and I can cancel the 8's there. And I'm left with x divided by 1, which is just x. So this is x divided by 8 is it no longer looks like a fraction. Over here, I can cancel with the 2. That becomes 4. 4 times negative 1. So this just becomes negative 4. And I can write that this way. I could just write that as negative 4 equals, over here I can also cancel, and this is 4, and 4 times negative 7 is negative 28. Now what do I do here? Well, to get x by itself, I use the addition property of equality. I get x all by itself equals negative 24. Does this work? Would this work in here? Well, if I put negative 24 and substitute it in here for x, then I have negative 24 divided by 8. So this would be negative 24 divided by 8 minus 1/2 equals negative 7/2. And negative 24 divided by 8 is negative 3. And negative 3 minus 1/2 is what? It's negative 3.5, which is the same as saying negative 7/2. So negative 24 is the solution. All right, let's move on. So here's another kind of equation. It looks similar to the one we had, and I can do the same thing. What is the least common denominator? I can put these values over 1. The least common denominator is 2. So multiply this entire equation, let me move this 4 out of the way here, by 2. So this is problem number 4. Again, let's use the distributive property. 2 times m divided, so 2 times m divided by 2 plus 2 times 6 equals 2 times 10. And then this part here, this just cancels. Leaves me with m plus 12 equals 20. I subtract 12 from both sides, and I end up with m equals 8. Okay, so a little bit of work there, but notice I go from having fractions that I'm dealing with, and those fractions are gone now when I go from this step to this step. Okay, so it's a pretty useful tool. So I'm going to have you pause the video right now, and I want you to work out problems 5 and 6 in your composition book. And if you're watching Edpuzzle, the video will pause now. All right, so we're back, and hopefully you were able to work out the solutions to problems 5 and 6. So let's take a look at what we got here. For number 5, I multiply this equation by the least common denominator, which is 3, and I do all the work, and I end up with z equals negative 12, which is the correct answer. And then for number 6, a little bit more work down here, I end up with a equals negative 2/5. All right, the least common denominator was 5, and you can see the work that I did. So some students will say, oh my gosh, that's a lot of work, that's a lot of work. This is actually not that much work. As you move up and when you get into algebra and algebra 2, you may end up working on problems that could take up a whole half a piece of paper or a whole piece of paper just to get the solution. So this is good practice that'll help you prepare for those days when you're working out a problem. You're like, man, Mr. Odom told me that I was going to have problems. They're going to take up a whole piece of paper, and he was wrong because this is taking up the front and the back. Okay, so let's move on. Let's look at this problem. 3y minus 8y equals 25. And we have to think back to section 3.1 when we were simplifying expressions. What did we have to do? So on this side of the expression, I have 3y minus 8y. And the question is, can I combine those? And the answer is yes, they are like terms. So 3y minus 8y is actually negative 5y. That equals 25. Can you solve the problem from here? Yes, you can. You can divide both sides by negative 5. The negative 5s cancel over here. I end up with y all by itself. And over here, I end up with an answer of negative 5. Okay? And if I want to check this, 3 times negative 5 minus 8 times negative 5, does that equal 25? Well, this is negative 15. This is 40. Does that equal 25? Negative 15 plus 40. You can check it in your calculator. You'll find that, yes, it does equal 25. So this is the solution to the equation. All right, so the last part of this video, I know this one's a little bit long, but this is like the meat and potatoes of this whole 7th grade math book, solving equations. So let's go ahead and let's solve this one. First, on this side of the equation, I see that there are like terms here. So let me combine those. What's 4 plus 3? It's 7 minus 2y equals negative 9. Now I have a two-step equation. First, subtract, whoops, not 2. That's not going to work, Mr. Odom. Subtract 7 from this side and subtract 7 from this side. That's using the subtraction property of equality. That leaves me with negative 2 times y equals negative 16. Now what do? I divide both sides by negative 2. And the negative 2's cancel here on the left-hand side. And I'm left with, on the right-hand side, negative 16 divided by negative 2, which is 8. Okay, and we can check that answer. So 4 minus 2 times 8 plus 3, does that equal negative 9? So the 4 plus the 3, we know that that's 7. Negative 2 times that's negative 16. So I have 7 minus 16. Does that equal negative 9? Yes, it does. Okay, so there we go. That means that this is the solution to that equation. All right, so the last piece of this video, I want you to work out problems 8 or 9. I should have said that above and I made a mistake. Hopefully I can fix it. We only had to work out one of those problems, 5 or 6. But here, problem 8 or 9. So just work out one of these problems and pause the video, do that, and we'll come back. If you're watching Edpuzzle, it'll pause now. All right, so we're back, and let's look at what we have for problems 8 and 9. So you can see the work that I did. I combined like terms here, and that gave me negative 3x. Divide both sides by negative 3. I get my solution. Over here, I combine 1.3m. I subtract 2.1m from that. I get negative 0.8. I divide both sides by negative 0.8. You can use your calculator for this side over here. I end up with 10. Okay. So that's it for section 3.5. It's a longer section. I apologize that there are lots of examples and things to work out, but this really is a very, very important section. So if you need to watch this video again, you can have me return your Edpuzzle assignment, or you can just go to my YouTube page and this will be listed in the section 3.5 videos. So that's it. That's all I have for now. Hopefully you're having a good day, and I look forward to working with you soon. Bye.